instances, it's a little easier to track, to identify
Right.
the source.
So, as you said, there is one mode of configuration called stateless address auto configuration, wherein the router says, okay, here I am, I'm the router, and here's the prefix that you're allowed to use, this /64. And so what then happens is the end device says, okay, I know what 64 I'm in. I'm going to take a permutation of my MAC address. It's usually the first 3 octets. There's a bit flip to indicate local global. There's an FFFE stuck in the middle, and then the last bits. So yeah, if you are using stateless autoconfig and you pick up your laptop and then go to some other network, you'll get a different prefix. But then that permutation of your MAC, essentially you're leaving your MAC footprint all over the net. And yeah, some ne'er-do-wells, like some of your bigger social networks might go, that's interesting, I can now track this guy without even needing a cookie. There's been a lot of thought put into that and said, that's perhaps not a great idea. And they came up with privacy extensions. I don't remember the RFC off the top of my head. But what it basically does is it essentially generates a random number for that last 64 bits that it then uses temporarily for outgoing connections for a certain amount of time, and then it recycles and generates a new set. So for end nodes, things that are roaming, that's actually pretty good, because then you're essentially using a random number, you're not easily trackable, and you can go on. Obviously for servers, that's not going to work too well. You want to do static, or you want to use that stateful, or not stateful, but you use the deterministic slack or something like that. But it is default in Windows 7, I think in Vista as well. Linux defaults to the Mac-based ones, but there is a switch you can flip to make it do the other.
Ubuntu 12.04 actually turns on privacy extensions by default now.
Ubuntu 12.04 has them on by default. Good to know.
Does it do that both on the server
I
ISO?
That's the one I upgraded recently.
Yeah.
So
it'd be interesting to test if they flip it one way or the other, depending on whether it's the server
kernel or the standard kernel. Yeah, that'll be. Well, if you've got the beta, you can bring it on Saturday and we can test some things out. I saw. Okay, right here.
What kind of, you mentioned latency before. How much of a latency hit are you taking on these tunnels?
What kind of latency hit are you taking on the tunnels? It basically varies with how distant you are to the tunnels. It ranges in like 10 to 40 mils from what I've seen. It depends on where your ISP is, how well peered they are. When you're setting up the tunnel, they usually tell you where the tunnel servers are, and you can do ping checks to see what you're going to start to see, what additional latency you're going to see. But I saw some more back here, yes?
Yeah, 6 is being turned on in June.
Yes.
Is there any projection of when they're going to turn off 4?
So we're launching IPv6 in June. When is IPv4 going to get turned off? Nobody knows. Yeah. Yeah, we're going to convert 4 billion nodes in 2 months.
I heard 2016.
2016
I
for.
think that's kind of a nebulous.
But yeah, I've heard figures for 5 years, 10 years, forever. Not forever. It's going to be too much of a nightmare. But so what's the rush in turning it off? The idea is you only want one protocol to really have to mess with. So you'll have this dual stack, and yeah, you can do stuff, but ideally you want to get down to one protocol, so you don't remember, okay, is this site on this network, or is this site on this network, or whatever.
Small embedded devices don't want the overhead in there.
Yeah. Small embedded devices.
Exactly, that's my question. With what, 1 billion ARM cores being shipped every year now, something like that, including cell phones, but also medical devices, industrial controllers, all that stuff.
Yeah, and a lot of those are still only V4. You've got a lot of old things out there.
And industrial medical devices, they don't like to change those.
Industrial medical
They're
devices,
shipping
yes.
2.4.
Yeah. So it is a bit of a challenge in terms of getting things to move. And like some of the medical devices, do they need global addresses? But on the other hand, you want to have to keep a legacy IPv4 network around in perpetuity, or do you want to get back to one single integrated network? It's going to be an interesting balancing act to see, once we've launched, once we've got V6 starting to ramp up, because when they originally designed V6 and they originally started pushing things out, the whole idea was we were supposed to be through this process long before IPv4 exhaustion ever happened. We procrastinate. It's human nature.
It's been, what, 15 years since
98 was the actual release date of the RFC, and then obviously it took a few years after that to start getting it into OSs. But the thing is, it's been in Linux and most of your other OS cores, at least in some level, the basic implementation, 10 years now. I thought I saw one back there somewhere.
How long till we run out of V6 addresses?
Hopefully long after our grandchildren are having to deal with this.
This will be a good time
Unix 6
to bring up,
is in 2032 or
bring up how big a number 2 to the 128 is.
Yeah, 2 to the 128th is,
So it
what is
really
it,
is-
undecillion?
Every atom on the surface of the planet could be assigned 1 million IP addresses.
Yeah, I've heard like however many millions for every grain of sand. One of the other ones I've heard is if the IPv4 space was a golf ball, the IPv6 space would be the size of the sun. One of them I heard was something on the order of if the IPv4 space was an M&M, the IPv6 space is the Great Lakes completely filled with M&Ms. I think we're okay for a while.
Conversion problem is probably going to be with programs, because a lot of people are running binaries.
Yeah, the conversion problem is going to be a lot at the application level, because we've already gotten to the point where a lot of the routers, backbones are all ready to go. Most of the end nodes, the OS is ready to go. But yeah, we're going to see a lot of application issues. How many people here have seen a database where you have like a SQL database where it says IP address varchar 15? What happens when I chuck a v6 address at that? What is your database going to do? Yeah, it's going to fall down. It's going
You'll see
to
that.
MySQL truncates. Postgres chucks it. I mean, what are these things going to do? These are things that we need to. That's why we need to get this stuff out now. Start testing this. Let's see what's going to break.
validation.
Yeah, you do your entry validation. See what's going to happen once we do this. We want to. One more question, then we'll start.
Not a question, just a comment. Is Windows 7 already uses V6 link local addresses just for all the land-based stuff?
Right.
So-
Yeah, the link local stuff, I think, and then, you're saying Vista and 7 do it. Mac OS, I think, uses, its Bonjour technology, can also do a link local v6 to find those services as well. So, enough blathering from me. Yeah, who's next? We have a couple of different demos already here.
Hello. So I'm Igor. Igor Partola. So I'm the lead developer at TriLUG. That's my license plate. Just because why not? And so I have a real IPv6 use case. I set up the tunnel at work and at home. TriLUG, we're not a large organization yet, so I was, plugged in a device and made it our IPv6 router. And so here's how I use it. So sometimes I work from home. It's not my actual couch, but I wish. And when I work from home, I need to SSH to my workstation at work because that's where most of my code lives. And we're behind a NAT, just like everybody. Time Warner gives us a dynamic IPv4 address, so that doesn't really help things. So with IPv4, our solution was we set up a VPN, so used OpenVPN. So it works great. OpenVPN is a great piece of software. The problem with it is somebody has to install it, somebody has to manage user accounts. We have to set up routing policies because it's on a different subnet than the main subnet and so on. So it's a solution, but it's not a great one. And the other thing is OpenVPN is not really supported by iPhones and Android phones, which is kind of a problem. So with IPv6, it's easy. I have a static IP address for my workstation at work. It has a global address. And I have an IPv6 address at home, so I just SSH to my address at work. This is literally what I type in. I set up, well, not quite literally. I have a global domain name set up through dns.he.net, which is another Hurricane Electric free thing. It's great. It's one of the best web-based DNS editors that I've seen. So basically, I just set up my IPv6 only address through there, and I SSH to work that way. There's a couple of sort of tricky points here. One of these is that you want to set up a firewall for these networks. So for my home, I set up basically a firewall at the router level, and it only lets in ICMP, so I can ping any machine there, and I can SSH, and that's it. So I can SSH from work to home the same way that I SSH from home to work. I was kind of surprised because I discovered that my printer has an IPv6 address. So that would have been kind of interesting if people start printing from the internet directly to me. This was a Brother printer, if anybody's looking. It's their little cheap wireless one.
Can you go back a slide? I want to get that address.
Sure, dns.he.net.
At work.
That's the one. So security is a little bit of an issue. And the other thing is, the way that it works with Hurricane Electric and Tunnel Broker is if your public IPv4 address changes, you need to let them know. So they have basically an API of sorts. So I set up a little shell script that runs every 10 minutes or so and checks whether the IP address has changed and lets Hurricane Electric know if it has. And I have another use case. I'm not sure what happened with the cutoff display here, but if I work from a coffee shop, so somewhere where I don't have access to the router, so they don't typically have IPv6 addresses yet. With IPv4, that's interesting. With IPv4, basically I still have to use OpenVPN. With IPv6, I set up something called Merito, or Torito, as the protocol is called. So this is kind of a terrible protocol. It's a last resort sort of thing. But the ideal thing about it is it's completely stateless. So I apt-get install Merito, and I have IPv6. The problem with it is it's a dynamic address, just like the 6 to 4 transition. This also gives you an address that will change every now and again. So I can't set this up on my workstation or my workstation at home, but I can set this up at a coffee shop where I can't set up proper tunnel. And as soon as I install this or fire it up, I'm on the internet, on the IPv6 internet, so I can SSH Igor at work. Sometimes you'll run into issues with this if there's a very strict firewall at that coffee shop, at which point you have to fall back on the OpenVPN solution. But most places don't have it that strict, so it works out. And I usually don't run this normally, so I'll set it up so that it doesn't start on startup for my laptop. It only starts when I specifically start it, and then I stop it when I'm done working from a coffee shop. So IPv6 is awesome, makes people productive. I use it every day, so makes people happy.
So just like Igor, we had this discussion a little bit earlier this week about cool slide packages that we can use here. So that's what was the package? Landslide?
Landslide.
We used here. I need to be able to type in a URL here.
Just go to the top, we already loaded.
It's already up there.
Yeah, that's good. Look at that.
Need to clear that.
All right, so my name's Alan Porter, and in my day job, I work at TechCollect, and we make routing equipment that phone companies use to route all sorts of different types of traffic, like SIP traffic, or a new protocol that's being used a lot in the 4G networks called Diameter. And so I've got a couple of photos of our Diameter router product. I know you're thinking, when somebody says router, you're thinking something like this, but actually our router looks more like what was in the first slide. It's huge and it's distributed, and one router might span the whole globe, but just think of it as a router. It's supposed to act like one of these, and oddly enough, the user interface looks a little bit like what these do. Only instead of configuring 6 static routes or something, you might configure 12,000. But anyway, that's what phone companies use to route their traffic. So this is what our user interface looks like. I guess it was about maybe sometime a year ago, they came up and said, hey, we need to add IPv6 support. So the interesting thing about, so the way I work on this product is just through the web interface. There are other people who handle all of the traffic routing and stuff like that. They're routing experts. So, so the project's divided into two pieces. My piece is only going to be the presentation, and then these routing guys are going to have to worry about like what sockets they listen to and getting back these structures with IP addresses. But here you see you've got local node 1, here is where it lives, it's fully qualified domain, it's ports. And then over here you've got its IP addresses, and we've got a 172 address, and then we've got a big long IPv6 address. So we needed to change our databases and our web interfaces to work with IPv6. And just like you said, these were 15-digit fields in a database. Well, now there are 39-digit fields in a database. And I'll show you a trick we did that was actually pretty cool to let things sort out really well. This is another screen that you would do if you were editing the same information. It basically just shows you all the same stuff, but down here you've got these little pull downs. They used to be about this wide, now they're about that wide. And so that's the big thing that people notice is that some of the fields have to be a lot bigger and take up a lot more space on the screen. So basically our job fell into just a few key categories. As on the web front end, we needed to check address ranges. So you're probably used to, in the v4 world, you want to check and see if you're in, like here I put the RFC 1918 addresses 10 dot whatever, 192.168, and 172.16. These are the three ranges that some might choose to filter out because they're in a private address space. We actually allow them because a lot of our routing products work in a private address space. But you do need to filter out addresses that fall in these specific areas. You know, these are limited broadcast. These are, you know, different RFCs say thou shalt not have an address in these ranges. So we have some of our PHP code. When you enter in an IP address, if it's 192.0.2 something, it's going to say, no, I'm sorry, that's against the rules. You're not supposed to be using a testnet address. So similarly, we have another table that looks almost like it, but this is where we check against the forbidden ranges for IPv6 addresses. And you see all your FFs over here, your multicast addresses. You've got some other special use addresses. These are the ULAs, the unique local addresses. We specifically allow these in our product because we use them in our lab. And when they first asked me to put this stuff together, you know, we need you to do whatever it is you have to do to make V6 work. That was the direction I had. So I made this list and said, well, it appears that we need to filter out some invalid addresses. I actually disallowed FC00, the unique local addresses, and then our testing department came back and said, hey, nothing works in our lab because I can't enter any of the addresses for our lab. So that's when I learned we're going to change our policy. There's also some really weird ones here with this. A whole bunch of zeros and then FF and then the last two, whatever you call those things, the last two little sections here are all zeros. The last 32 bits are zeros, and you'll see those in a minute.
What did he say they were called?
Blobs, chunks, I don't know, I'm just
Yeah.
making something up.
So what these are called, those are actually called IPv4 mapped ranges. And there are some cases where you need to actually specify an address that looks like this. A bunch of zeros, one chunk of Fs, and then actually dotted quads at the end. Or you can specify the same address in hex by doing this. 172.31 turns into AC1F. So I had to ask Kevin about this when we encountered this. Those are legitimate notations for IP addresses, and they're for very special use for cases where you need to map a particular existing IPv4 range to the v6 address space. But it's still the v6 protocol.
It's mostly used where if you're trying to write an app where you only want to open an AFINET6 socket family,
and so you don't want to have to necessarily do the full dual stacking. You can open it up and then tell it, make a connection to that address, and it will then still, the OS then knows to go ahead and make the standard v4 connection.
So it's sort of mapped at the v4 level, I mean at the OS level.
Is this gonna lead to the same type of problem where we have a lot of wasted space in the IPv4? That you're wasting a lot of space with IPv6?
Well, these are the v4 addresses, and then I think they would only be used on a, like a very local level, not global
That is
addresses.
a chunk of IPv6 space that you technically can't use, but there's so much that is still usable that, you know, we can take the hit for the transition and it's not going to.
So the interesting thing is, I have a little chunk of code down here that nobody's going to read. But what's interesting about it is, if a range is excluded from the v4, an excluded v4 range like this one, 192.0.0.2, it also needs to be excluded from the 0.0.0.0.FF 192.0.2.x. So that's what this little chunk of code does. It says, do the same stuff.
Sorry, your friend.
So the thing I kind of wanted to point out here is, if I back up, I'm trying to find where I wrote. Okay, I didn't. So I had to have a couple of little functions that just checked to see whether an address was a valid address. Then there was this whole idea of whatever it is somebody enters, because there's so many different ways you can enter addresses in v6. You need to be able to accept that, but then you need to be able to print it out in some sort of sane way that you're not going to drive your users crazy. And then there was this whole idea of comparing two IP addresses, you know, regardless of how they've been entered. So the solution we came up with is always store in the database in a fully expanded form, whether it's IPv6 or v4. So it looks a little funny in v4 to say 010, even though technically that means that's an octal address. We're ignoring that because our assumption is, if you're buying our equipment for an LTE network, we hope you're not using octal in your IP address scheme. But so basically you have fully expanded with leading zeros, so that all v4 addresses are 15 digits and all v6 addresses are all 39 digits. And then it makes it really nice to be able to pull out of the database in sorted order. And if you sort them, you also happen to get all your v4s in one chunk and all your v6s in one chunk. So lots of really neat things happen. So basically, we had to write one function called fully expand IP, and that's all that does. If you're going to display things on the screen, you wanted it in what I call the canonical format, which is fully compressed. So you want to take away the leading zeros, and you want to squishify all the zeros that are in the middle using the squishified colon notation.
What's the name of the function?
It's called canonicalized IP.
No, I was gonna say switchify.
It is not. But, so there's one of our three functions used for display and input. And then the third one is a trivial, I have this trivial regular expression.
Can I get this?
Yeah, I didn't write this. I did find this on the internet and gladly stole it. It is great. Absolutely great. But it basically is called, it's a function called, exactly. Now you have two problems. So this function is called validate IP. So if you type in an IP address, this regular expression is just for v6. For v4, I think it was so simple we just did a little bit of 6 lines of math or something to figure it out. But this works. And so how do you know it works? You test it. So at the same place that I found this regular expression, I found this collection where they had been building a list of every possible way you can express correct and incorrect IP addresses. And also with the caveat that some of them are in these private zones that aren't supposed to be used, the special RFC zones, and some of them are wide open. So I've just made a list of a few of them here. You've got the 10 dot range. So we have this set of PHP unit tests that will run through the regular expressions, those 3 new functions, and try every single address in this torture test here, and there's a little over 200 of them, I think. And it basically says, you know, we expect this one to be good, and so run the unit test and make sure that this one does pass. But we expect this one to be bad. 127.0.0.0 should not be accepted by our system. We should consider that an invalid address. So there's a little subtle distinction here. The good and bad means, do we accept this as input? It doesn't mean, is this a valid IP address? So this would be considered invalid input on our system, anywhere you tried to enter it. So we've got a few more that are a little bit goofier looking, with lots of little colons and stuff. Dotted notation with hex digits in there and octal stuff. And here's 192.0:0:2 something, followed by 192.0.2 something. And I don't know what these guys were smoking when they came up with this list, but I love it.
Or even the first two in that group, Alan.
What was that?
I said, or even the first two in that group.
Yeah, colon.
No.